What if I told you there's something out there so massive, so incomprehensibly huge, that it makes entire galaxies look tiny in comparison? A black hole so gigantic, it defies everything we thought we knew about the universe. Where is it? How did it get so big? And what does it mean for us? Today, we're diving into the terrifying mystery of the largest black hole ever discovered. But be warned, once you understand its true scale, you may never look at the night sky the same way again. When we think about the biggest things in the universe, we usually picture giant planets or massive stars. But even those are nothing compared to black holes. These cosmic monsters don't have a physical size limit. They can keep growing endlessly, devouring anything that comes too close. But the truth is, black holes don't all start the same way. Different conditions give birth to different kinds of black holes, from the tiniest ones, smaller than an atom, to the largest single objects in existence. So, how exactly do black holes grow? And just how massive can the biggest one get? Now, this video isn't about the basics of how black holes work or how they form. We've already covered all that in detail in our Black Hole and Neutron Star series, which you can check out afterward. Right now, we're going on a journey to track down the biggest thing in the entire universe. And to do that, we need to begin at the opposite extreme, with the tiniest black holes, the ones that may not even exist. These are known as primordial black holes, the smallest type of black hole ever theorized. If they're real, they could be the oldest objects in the universe, older than atoms themselves. Formed just moments after the Big Bang, during a time when the universe was a chaotic mess of raw, violent energy, any tiny area just slightly denser than its surroundings might have collapsed into a black hole. A primordial black hole, still surviving today, would have a mass of about 8 trillion kilograms. That's roughly the weight of a mountain. But in size, no bigger than a proton. A black hole with the mass of Earth would be barely larger than a coin. That makes them extremely difficult to detect, which is why we've never seen one, at least not yet. But if they do exist, they might just solve one of the universe's greatest mysteries: dark matter. These invisible objects could be what's holding galaxies together. Now let's leave theory behind and focus on the black holes we know are out there: stellar black holes. These form when matter collapses in on itself under extreme gravity. And once a black hole is born, it's all about growth. The more mass it consumes, the bigger and scarier it gets. In today's universe, only the most extreme and violent cosmic events can create the right conditions to form new black holes. Like when two neutron stars crash into each other, or when the core of a massive star collapses during a supernova explosion. To help us make sense of the sizes we're dealing with, let's use our sun as a measuring stick. It weighs around 2 million trillion kilograms. That's the unit we'll stick with from here on out. The smallest known black hole discovered so far has about 2.7 times the mass of our sun. That's still enough to squeeze all that matter into a sphere just 16 kilometers wide, roughly the size of Paris. Another example is a black hole paired with the red giant star V723 That star is 24 times more massive than the sun, stretching across 30 million kilometers. And yet, it's being flung around in space by a black hole no more than 17.2 kilometers wide. Imagine that. something the size of a small city tossing around an object the size of a star. It's such a dramatic mismatch that if we tried to show both in the same scale, the black hole would barely even appear. But even among stellar black holes, some are true monsters. One of the largest known is M33X7. It's currently feeding on a 70 solar mass blue giant star, slowly devouring it piece by piece. As the shredded star matter spirals into the black hole like water circling a drain, it heats up and begins to shine with incredible energy, about 500,000 times brighter than our sun. And yet, X7 itself, still relatively small, just 15.65 solar masses and 92 kilometers wide. That's only big enough to cast a shadow over a region the size of Corsica. If black holes want to get even bigger than this, they have to do more than just eat stars. They need to merge with other black holes. And thanks to new instruments that can detect these cosmic collisions, we're now uncovering some truly wild discoveries. Like the time we detected two massive black holes in a galaxy 17 billion light years away, locked in a violent spiral. As they slammed together, they unleashed more energy in the form of gravitational waves than all the stars in the Milky Way combined would emit in 4,400 years. The result? A brand new black hole with a mass of 142 suns and a size roughly equivalent to Germany. And this is where things get weird. We found plenty of black holes up to about 150 solar masses. But then, nothing. There's a huge gap. And suddenly, out of nowhere, we find black holes that are millions of times more massive. That's confusing because if black holes are supposed to grow gradually over time, you'd expect to see everything in between. But the truth is, this slow and steady growth just isn't fast enough to explain the existence of supermassive black holes today. The universe simply hasn't been around long enough for them to reach that size just by eating stars and merging. Something else must have happened to explain how the biggest black holes in the universe came to be. To understand it, we may need to consider the most massive stars that may have ever existed, quasi-stars. These aren't just bigger versions of today's stars. They're on a whole different level. To give you some perspective, our sun would be like a tiny grain of sand compared to these cosmic giants. We're not even sure quasi-stars ever really existed, but they're a fascinating idea when it comes to supercharging black hole growth. The theory goes like this. In the early universe, matter was packed together far more densely than it is now. Under these extreme conditions, quasi-stars could have grown to thousands of times the mass of our sun. And here's the wild part. Their cores might have been so heavy that they collapsed into black holes before the stars even finished forming. That's a huge contrast to modern stars. Today, if a star tried to do that, it would just rip itself apart. But inside quasi-stars, there may have been a kind of deadly balance. Gravity kept pushing the massive star inward, feeding the newborn black hole at its core. As matter spiraled in, it got superheated, producing intense radiation. That radiation pushed outward, creating just enough pressure to keep the star from collapsing completely. In this unique state, the growing black hole could feed on the star from within for millions of years, getting larger and larger, way beyond what we see in modern stellar black holes. We're talking about black holes thousands of times the mass of our sun, and so wide they'd stretch farther than the entire Earth. These cosmic beasts may have become the seeds, the first building blocks, for the supermassive black holes we see today. Which brings us to the reigning giants of the universe, the supermassive black holes. These are the largest single objects in existence, found at the heart of nearly every galaxy. They are monstrous. Take our own Milky Way, for example. At its center is a black hole called Sagittarius, a star. It has about 4 million times the mass of our sun, and yet it just sits there calmly, doing its thing. We know it's there because we can observe nearby stars being violently thrown around by something invisible. And that something has to be incredibly massive. And despite its mass, its radius is only about 17 times that of the sun. It's actually smaller than many giant stars, but it's millions of times heavier. Because they're so huge and located in the middle of galaxies, many people imagine supermassive black holes like giant anchors, like the sun is to the solar system, holding everything in place. But that's actually a misconception. In our solar system, the sun makes up a staggering 99.86% of all the mass, which is why everything orbits it. But in a galaxy, the supermassive black hole usually only accounts for about 0.001% of the total mass. It's more like a powerful bystander than the central boss we often picture. The billions of stars inside galaxies aren't actually being held together by the galaxies themselves. It's not the visible stuff doing the heavy lifting. It's the mysterious gravitational grip of dark matter that keeps everything from flying apart. And as for the giant black holes at the center of galaxies, not all of them are peaceful monsters. When they're actively feeding on the swirling clouds of gas and dust around them, they can become cosmic engines of destruction. Take the black hole at the heart of the BL Lacerta BL Lac galaxy, for example. It's devouring so much matter that it blasts out powerful jets of plasma, beams of raw energy moving at nearly the speed of light. If Earth were somehow orbiting this beast, it would look 115 times bigger than our sun in the sky. But you wouldn't get the chance to admire it. Its glowing, superheated accretion disk would incinerate the planet in seconds. At this scale, stars start to seem absolutely insignificant. Consider the galaxy Cygnus A, which hosts a supermassive black hole weighing in at 2.5 billion solar masses and stretching across 14.7 billion kilometers. That's so huge that if it replaced our sun, it would swallow every single planet and extend halfway to the edge of the solar system. And it's not just sitting there. It's devouring so much gas that the material spiraling in forms a blazing disk, twisted into a kind of magnetic funnel that launches jets of particles out into space. Jets so massive they carve out radio lobes that tower over the galaxy. These lobes are 500,000 light years wide. That's 2.5 times the diameter of the entire Milky Way. Another famous supermassive black hole sits in Messier 87, or M87. It's a true heavyweight at 6.5 billion solar masses, and it was the first black hole ever captured in a photo, or more precisely, an image of the hot gas glowing around its event horizon, revealing the ominous dark shadow at its core. This terrifying void is so massive it would completely engulf our solar system, and we're still not at the biggest scale. Because above supermassive black holes, there's another category, ultramassive black holes. Now we've arrived at the true kings of the cosmos, the largest individual objects that may ever exist in the universe. These monsters have gorged on so much matter that they've reached tens of billions of solar masses. Their intense gravity fuels quasars, which shine brighter than thousands of entire galaxies combined. They're so enormous, they deserve a new title: ultra-massive black holes. One of the most extreme examples lies at the center of the galaxy OJ287. This black hole tips the cosmic scale at a staggering 18 billion solar masses. And it's not alone. It has its own companion, a supermassive black hole that's almost 40 times larger than Sagittarius A, the one at the center of our own Milky Way, and it's orbiting it. This cosmic titan is beyond imagination. It's so enormous, you could line up 3 entire solar systems side by side inside its event horizon and still have room to spare. Let's wrap up this cosmic showdown and meet the undisputed champion, TON 618, a black hole so massive, so mind-bendingly huge that it makes every other black hole we've seen look puny. This monster isn't just sitting there quietly. It's actively devouring entire galaxies worth of matter, and it's doing it with style, shining with the light of 100 trillion stars. That's so bright, we can see it from 18 billion light years away. TON 618 holds an estimated 66 billion solar masses, a number so big it's nearly impossible to grasp. If you crossed its event horizon, light itself would take an entire week to reach the singularity at its center. Imagine that. And its size, you could line up 11 whole solar systems inside of it, side by side. This might be the largest single object in the entire universe. But there's a twist. TON 618 is so far away that we're not seeing it as it is now. We're looking 10 billion years into the past. So in reality, it could be even more massive today. And that's the wild part. Black holes are terrifying, mysterious, and absurdly gigantic, and they're not going anywhere. Long after everything else has faded away, black holes will still be growing, slowly swallowing the universe piece by piece. All right, now that we've met the biggest monster of them all, let's take the journey one more time, from the tiniest possible black hole to the largest known colossus in existence. But before we wrap things up, let's try something a little different. Welcome to Behind the Lies, a short peek behind the curtain to talk about some of the unavoidable inaccuracies in this video. Because here's the truth. Ranking black holes like they're Pokemon cards just isn't scientifically precise. Why? Well, while we've discovered millions of stars, we've only got solid data on a few dozen black holes. And it's not because they're rare, it's because they're incredibly hard to detect. Black hole research only really kicked off about 50 years ago, and even now, we can't observe them directly. We can only infer their properties by studying how their gravity affects the matter and stars around them. That means we have to rely on indirect measurements, like tracking how fast stars orbit near a suspected black hole. And those calculations come with massive uncertainties. Even when we use physics tools like Kepler's laws, we're still dealing with big margins of error and assumptions. So, as incredible as these numbers and visuals are, remember, there's still so much we don't know. And that's what makes black holes not just fascinating, but one of the greatest mysteries of the cosmos. Then comes the tricky part, converting mass into size, and that's where even more uncertainties creep in. To figure out the radius of a black hole, we usually turn to the Schwarzschild equation, a neat little formula from general relativity. But here's the catch. That equation assumes a black hole is a perfect non-spinning sphere, a kind of idealized black hole that doesn't actually exist in the real universe. Real black holes spin like crazy, twist space and time, and are far from simple. So when we throw around exact sizes, remember, we're simplifying an incredibly messy, chaotic reality just to make sense of it all. The truth is, when you're dealing with physics on such extreme scales, things get a little fuzzy. That means some of the black holes we've talked about here could actually be much smaller or much larger than we think. The problem is, we just don't know for sure. So to work around all this uncertainty, we cross-referenced different studies, used a variety of mass estimation methods, and compared sources with slightly different numbers to create a standardized list. That way, we could get as close to accurate as humanly possible, while still giving you a picture that makes sense. So while black holes might be the biggest, most mysterious forces in the universe, there's another force that's wildly underestimated: your own brain. Think about it. Black holes bend time, devour stars, and reshape entire galaxies. But your mind? It shapes your reality, your future, and the limits of what you believe is possible. The difference? You haven't fully unlocked it yet. That's why we created the Genius Wave, an exclusive digital tool designed to activate your brain's hidden potential, accelerate your thinking, boost your memory, and take you light years ahead of the average person. Imagine mastering focus, creativity, and mental clarity. With the same intensity, a black hole dominates gravity. And here's the best part. For a limited time, you can get access to everything at an 80% discount. But hurry, this offer is temporary and only available for those watching this video right now. Click the link below, take the first step, and begin exploring the most powerful universe that exists, your mind.